Hello everyone, this is Wendell. Today we're going to continue our competition maths series, and we will be answering this Hong Kong International Mathematical Olympiad 2018 test, primary 2 level. Let's start. For the first problem, if the day after tomorrow is Wednesday, which day of the week the day before yesterday is? So the day after tomorrow is Wednesday, it means today is Monday. So the day before yesterday, if today is Monday, is Saturday. So our answer here is Saturday. For question number 2, 16 children form a column. Amy is the 7th position, counting from the front. What is her position counting from behind? So for the 16 children, Amy is the number 7th. So from behind, she must be the 10th, because if she's number 7, for example, we write their positions as 1, 2, 3, 4, 5, 6, 7 up to 16, because there are 16 children. Amy is the 7th, so counting from behind or from the last position, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Her position from behind is 10th. Number 3. According to the pattern shown below, what is the number in the blank? It looks like the pattern in this series is plus, this is plus 3, and then plus 4, plus 5, plus 6, plus 7, because 28 plus 7, 21 plus 7 is 28. So the next one should be plus 8. So 28 plus 8, that should give us 36. So the answer here is 36. Next problem, number 4. John goes home by taxi and he needs to pay $90. How much does he has to pay if he goes home by taxi with his father, mother, and sister? Of course, he will pay $90 also, because regardless of the number of people, there will be the same amount of for the taxi meter reading, so he will pay the same amount, 90. For number 5 problem, according to the pattern shown below, how many this symbol, a circle with an X, is or are there in the 12th group? Alright, so for the first group, we have 1 square with 1 of this symbol. Second group, 5 squares, or so 5 of these symbols also. Each square with 1 of these symbols. And the third group, it's 9. For the fourth group, it is 13. So it looks like the pattern for the number of squares or the number of symbols here are 1, 5, 9, and then for the fourth group it's 13. If we continue this pattern, how many of these symbols are there in the 12th group? So we can make here an algorithm or a formula. 1 plus 0 times 4. This will be 1 plus or 0 times 4 or 4 times 0. And this will be 1 plus 4 times 1. This will be 1 times 4 times 2. And this will be 1 plus 4 times 3. So in the 12th pattern, in the 12th group, it should be 1 plus 4 times 11, because as you can see in the fourth group, fourth group here, it's 1 plus 4 times 3. So for the fourth group, it's 3 here. Similarly, in the 12th group, it should be 11 here, 12 minus 1. So our answer will be 45. There will be 45 of this symbol in the 12th group. Okay, let's go over to the next page. For arithmetic part, problem number 6. Find the value of 2 plus 8 plus 12 plus 18 plus 22 plus 25 plus 28 plus 35. So the easiest way to add these numbers is grouping them by pair, wherein each pair has a sum of what can we do here? Sum of a number which is divisible by 10. It looks like this is 10, this is 30, and this sums to 50, and this sums to 60. So our answer will be 10 plus 30, 40 plus 50, 90 plus 60, 150. So the answer is 150, the sum of these numbers. For number 7, find the value of 105 divided by 3 minus 105 divided by 5 plus 105 divided by 7. So by the rule of mixed operations, we have to do division first before addition or subtraction. So we have to do this group first, and then this group, and then this group. For 105 divided by 3, the answer of that is 35. 105 divided by 5 is 21, and 105 divided by 7 is 15. So this expression simplifies to 35 minus 21 plus 15, which is equal to 29. So the answer is 29. Number 8, find the value of 22 minus 19 plus 16 minus 13 plus 10 minus 7 plus 4 minus 1. To simplify this one, because since this is primary 2 level or grade 2 level, you may group the numbers by 2. So it looks like here the difference of 22 and 19 is 3, and this is also 3. 10 minus 7 is also 3, and it's also 3, and that simplifies to 3 plus 3 plus 3 plus 3, or 12. That is our answer. Number 9, what is the number that should be filled in the blank if the equation below is correct? What is blank times 45 equals 405? We may do here trial and error. It looks like 450 times 10, 45 times 10 is 450. If we subtract 45 from here, we will get exactly 405. So it should be 45 times 9. So this should be 9. The answer in the blank is 9. For number 10, if A and B are different one-digit numbers, what is the value of A if the equation is correct? Since A and B have different values, we may try here different values of A and B. Let's try first. What if the value of B is 1? So this is also 1. And this is 14. And this is also 1 here. It looks like it's not possible to find an A something 1 plus 1 to get 14, because the last digits here, or the units digits are 1 and 1. That is impossible to become 4 here. So that is not possible. What about if B is 2? If B is 2, something plus 2 equals 24. So the only possible value of A is 2, which is incorrect because A and B should have different values. They cannot have the same values, so they cannot be both 2. So that is not the answer. Let's try 3 for our B. So what is blank something 3 plus 3 equals 34? Again, it is not possible to get 4 here in the units digit with 3 and 3 here in the units digit. So that is not the correct answer. What if B is 4? Again, that is not possible since... Oh, wait a minute. What if B is 4? So this part should be 44. So what is blank 4 plus 4 equals 44? There is no such number which when we add here and here that we will get 44. So that is not the answer. Let's try 5 for the B. So what is blank 5 plus 5? And we will get 54. That is not also possible since 5 plus 5 is 10. So this must be 0 here. What about 6 for B? Okay, 6. Blank 6 plus 6 equals 64. That is not also possible. So we move to 7 for the value P. And it looks like it is exactly 67. 67 plus 7 equals 74. So this is the correct equation. Therefore, the value of A is 6. Therefore, A equals 6. For number 11, Amy has 73 apples and John has 39 apples. How many apples does Amy have to give John to make them have the same number of apples? For these two people to have the same number of apples, they should have 73 plus 39 divided by 2 apples. Total number of apples for these two people is 112. When you divide it by 2, each should have 56. Now Amy has 73 now. How many apples does he need to give to John for them to have the same number of apples? So that would be 73 minus 56. So 73 minus 56 equals 7. Is it 17? Yeah. No. Oh yes, sorry. So 17 apples. So Amy has to give John 17 apples so that both of them will have 56 apples each. Alright. For number 12, 4 students have 38 balloons in total. 2 children have even number of balloons and 1 child has odd number of balloons. Determine the number of balloons of the remaining child. So it looks like the question here is the number of balloons of the remaining child odd or even? Since the 2 children have even number of balloons and the other child, the third child, has odd number. So the fourth child or the remaining child must have an odd number of balloons since the total number of balloons is even. Because that would be even plus odd. This is the number of balloons for the first child and the second child. Both have even number of balloons, and the third child has odd number of balloons. For the answer to be even, the remaining child must have odd number of balloons. So the answer is odd. We cannot assign any specific number of balloons for each child since there are many different values for that. So the answer is odd. For number 13, the numbers below follow the arithmetic sequence. What is the 11th number? For this problem, it looks like the pattern is -3, -3, and -3. Is that correct? Sorry, not minus 3 but minus 4. 143 minus 4 is 139, minus 4 135, minus 4 131, minus 4 127. So if we continue this pattern, the next number should be 123, and then 119, and then 115, and then 111, and then 107, 103. So we're looking for the 11th number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the answer is 103. Number of the 11th number in this sequence is 103. Number 14. How many 3-digit numbers having the units digit 1 is or are there? 3-digit numbers with 1 in the units digit. So for it to become a 3-digit number, you cannot have 0 as the first digit. So the smallest one units digit, hundreds digit here is 1. So we can have 1, 0, 1, and then to have a 1 in our units digit, and then it could be 111, 121, up to 191. So these are the 3-digit numbers with 1 in the units digit, and also 1 in the hundreds digit. With this pattern, we can also have 201, 211, up to 291. And this applies to 301, 311 to 391. And for each group here, there are exactly 10 3-digit numbers. 101 to 191, that's 10 numbers. 201 to 291, that's 10 numbers. 301 to 391, that's 10 numbers. And this pattern continues to 901, 911 to 991. So there will be 9 groups, and in each group there are 10 3-digit numbers. So the total number of 3-digit numbers having the units digit as 1 is 9 times 10, or 90. That is our answer. Moving to the next problem, number 15. Fill the lines with plus and times to make the equation below correct. So we can only use addition or multiplication operations to make this equation correct. So what we'll do here is we can do this by trial and error method, but it looks like if you if you add 1 and 2, you will get 3, and then you add again here, you'll get 6, and when you multiply, 1 plus 2 is 3, plus 3, that is 6. We have to multiply this first. 3 times 4, that's 12, plus 3, 15, and this will be plus 5. So this is the correct equation. This will be 12, plus 5 is 17, plus 2, 19, plus 1, 20. Number 16, we are now in the geometry part. Problem number 16. How many squares are there in the figure below? So let's count the number of squares with 1 unit in each side first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 14 squares with 1 unit on each side. For squares with 2 units on each side, that's 1, 1, 2, 3, and 4, and 5, and 6, and 7. And that is 7. And for squares with 3 units on each side. That is 1, this one 1, and this is another one, so 2. So the total number of squares in this figure is 23. Number 17, a prism has 9 faces. How many vertices does this prism have? So for any prism, the base should have a number of faces minus 2 sides. So our faces is 9. So take away the 2 faces, which are the bases. So each base should have 9 sides, so, or should be a polygon with 7 sides. So since this prism has a base with 7 sides, the number of vertices in this prism will be 7 times 2, or 14. So there are 14 vertices, because for each base there are 7 vertices, and we have 2 bases. 7 times 2, or 7 plus 7, 14. For number 18, according to the pattern below, what is the figure in the space provided? So this looks like a pattern of 5. So for every 5 figures, the pattern repeats. So that would be circle, square, square, triangle, circle. Circle, square, square, triangle, circle, circle, square, square, triangle. So this one here must be a circle. So the answer is circle in the next figure. The next shape here in the blank must be a circle. Number 19. At least how many squares can be seen if viewing the figure below from the top? So for the top view, we can say this square, this 1, 2, also this 1, 3, and 4, 5, 6. So there are 6 squares that can be seen if we view this from the top. This one here is not, this is the side. It's also side here and side, so that is not a square that we can view from the top. So only 1, 2, 3, 4, 5, 6. 20. At most, how many rectangles can be found by drawing 5 straight lines on a plane? If we draw 5 straight lines, we may start with drawing a rectangle, and that is 4 lines already. So either way, if we draw another line, we will only have 3 rectangles. That is 1, 2, and the whole 3. So there are at most 3 rectangles that can be formed by drawing 5 straight lines on a plane. For number 21, this will be the last part, the combinatorics part. Number 21, after Amy gives 3 apples to Andy and 7 apples to Johnny, they will have equal number of apples. How many apples did Amy have more than Johnny originally? So Amy gives 3 apples to Andy and 7 to Johnny. So there are 3 people here: Amy, Andy, and Johnny. So Amy gives 3 to Andy and 7 to Johnny. So Amy is minus 10, Andy plus 3, Johnny plus 7. For these 3 people to have equal number of apples, we could assume that Johnny originally has 0 apples, Andy has 4 to make it 7. To make this 7 also, Amy could originally have 17 apples. 17 minus 10 is 7, 4 plus 3 is 7, 0 plus 7 is 7. So the three now have the same number of apples. Now the question is, how many apples did Amy have more than Johnny originally? Originally, Amy has 17 in this case, and Johnny 0. So Amy has 17 more apples than Johnny. The answer is 17. 22. What is the smallest four-digit number by using 3, 5, 6, and 8 that is divisible by 5? For any number to be divisible by 5, the last digit or the units digit should be either 0 or 5. So, what is the smallest four-digit number? To have the smallest four-digit number, our thousandths digit should be the smallest number among the three, and that could not be 5 because 5 should be the units digit. So 5 will be the units digit, and this should be the smallest number here, and the next digit or the hundredths digit should be the next smallest, but not 5. So it should be 6, and the 8 should be here. So the smallest four-digit number is 365. That is divisible by 5. The 5 should be here. Next, 3,685. Number 23. Every 2 of the 6 children shake hands. How many times do they shake hands? So there are 6 children. 1, 2, 3, 4, 5, 6. When you say shake hands, we connect a line between each 2 children. So this line means these two shake hands. Also this one can shake hand with that student, also that one. This can shake hand to the student, and that one, this and this, and this and this. These two can also shake hands. These two can also shake hands. These two can shake hands. These two can shake hands, can shake hands, can shake hands. So how many different shake hands happen? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, and then 8, 9, 10, 11, 12, 13, 14, 15. There are 15 different lines that connect any two of these points. So there are 15 shake hands for these 6 children. Number 24. How many odd numbers are there in the following numbers from 1st to 30th? So for numbers 1, 2, 3, 5, 8, 13. So the pattern here is we get the next number by adding the 2 previous numbers. It is commonly called the Fibonacci sequence. So if we continue this pattern, 1 plus 2 is 3, 2 plus 3 is 5, 2 plus 5 is 8, 8 plus 5 is 13, 13 plus 8 is 21, 21 plus 8 is 34, and if we continue doing this pattern, we should be able to have 15 numbers. That's a very long way to do. I cannot show it now, but you can check by yourself. Continuing this pattern up to the 30th number, there are 15 odd numbers. Number 25. Jack has 6 $1 coins, 4 $2 coins, and 2 $5 coins. How many ways can he buy for a souvenir? Costs $8 without any changes. So the possible ways to buy a souvenir with $8 is first 6 times $1 plus 1 times $2. So that is $8. That's one way. Or it could be 4 of the $1 coins and 2 of the $2 coins. That is also 8. Or it could be 2 of the $1 coins and 3 of the $2 coins. That's also 8. Or it could be 4 of $2 coins. That's also 8. And it could be also one $5 coin plus 3 $1 coins. That's also 8. And lastly, it could be one $5 coin plus one $2 coin plus one $1 coin. So there are 1, 2, 3, 4, 5, 6 ways to do this. Okay, that's all. Thank you.